Okay, so welcome back. In this session, we will cover dynamic method dispatch. That is actually a runtime polymorphism, which is principle 3 of object-oriented programming. In order to understand this dynamic method dispatch, uh, you need to recall the concept that we have covered in the previous few lectures. If you remember, we discussed that reference of the base class can store object of the derived class. And then you have also covered method overriding. So these two things, these two capabilities of Java actually make possible to implement dynamic method dispatch, or you can call it runtime polymorphism. In this example, as I told you earlier, when we have a reference of the base class and when we have object of the derived class, then it is the reference which will decide that which methods are possible to be called, and then it is object of the derived class which will actually decide which version of the overridden methods will be called. Right, I think you can better understand this whole phenomena with some example. So let us write a very common example that we usually see when we cover polymorphism. Right, so say for example we have got a class animal, right, and then we have a class cat that extends from animal, right, and then we have got another class dog that extends from animal, right, and then I have got, say for example, another class, I call it horse, that also extends from animal, right, and then here I will have a class animal demo that that will include public static void main string arg. Okay, now I save this program, control S, yes, March 26, I call it animal demo dot java. Right, now what we are going to do, inside animal class we have a method public void sound, right. Now this is the sound method, and we really don't know which animal we are talking about, so at this stage we have to keep the sound method empty because we don't know which animal we are talking about. So this method has to be empty. We cannot decide which animal we are talking about because animal is quite an abstract concept. When you talk about animal, many animals come to your mind, but there is nothing concrete. So obviously you cannot decide which sound this animal should make, right. But when you come here, then things are clear, right. When you override this method, control C, I'm going to override sound inside cat. Now when you override sound inside cat, you don't need to keep it empty. Now you know that this has to be meow, right, meow. Okay, so this is the sound of the cat. And then when you come to dog, you know that the sound of dog is this one, right. Okay, similarly when you come to horse, the horse sound is like this, right. Okay, so we have kind of created an animal and then three classes which are being extended from animal, and each of them is overriding the method from class animal. Overriding means same method, same signature. So you can see here the method is same and signature is also same, right. Now say for example, if I have inside cat, I have public void, say for example food, right. Now the food for the cat system dot out dot println. Food for the cat is, say for example, milk. Right. Now you know that when you have reference of animal class and you have object of cat class, you can call sound method, but you cannot call food method, because food method is a method which is more specifically created by cat and which is not available inside animal. So you cannot call this food method with the reference of animal. Right, we have already discussed this in our past lecture, so it was just a kind of repetition of the same concept. Okay, and even more, if you have more method, for example, inside animal, if I say public void and this animal, say for example animal type, right, animal type. This method at this stage has to be empty. System dot out dot println no type defined, because we don't know which animal we are talking about. Right. So if you have a reference of animal and object of cat, remember you can call sound, you can call animal type method, but you cannot call food method. Right. So these two methods are possible to be called, but this method cannot be called if you have reference of animal and object of cat. And remember, when you call sound on the reference of animal and object of cat, this sound will not be called, rather the sound from the derived class will be called, right, because it is always defined by the object, which version of the method will be called. So it will be the version from the class whose object is stored in the reference. So because object is of the cat, so method from cat will be called, right. But when you talk about this method, because this is not overridden method, so obviously this will be called from the base class, and this method will not be called at all, because this method, the reference of the animal A does not know the food method, right. So we got all this understanding that which method can be called and which method cannot be called. Now what we are going to do, we are going to play with it. See what I'm going to do. Here I create a reference animal A, reference of base class, right, and then cat C equal to new cat, right, and then dog B equal to new dog, right, and horse H equal to new horse, right. So we create a 3 object. Okay, now I'm going to introduce a new concept to you in this class, generating a random number. So in java.util package we have a class random, right, random. I name its reference as random, and then I create object of class random, right. So object of class random has been created. Now inside this random class we have multiple methods, and one of the method is to generate next int. So when I say random dot next int, this will give me next integer, right, but it will generate a random number that will be different every time you run the program, right. So say for example, if I write here maybe to 3, it means that this program will now generate a random number between 0 and 3. This will generate a random number between 0 and 3, right. So sometime when it runs, it may generate 0, other time when you run it, it may generate 1, it may generate 2. So whenever you run it, it will be generating a random number. And if you do not provide a range, like here I have provided 3, if you do not provide a range, it will generate random number in the integer range, right. And that integer range, it is 2 power 31, from 0 to 2 power 31. In fact, minus 2 power 31 to minus 2 power 32 to plus 2 power 31, right. So it can generate a random number in that integer range. But if you mention here range, say for example you say 20, it means that you are now saying generate a random number from 0 to 20. But if you say 0 to 3, it means it will be generating a random number from 0 to 3. Right? Okay. And when I don't let me check it. Maybe even before running this program, if I show you this example, it will make random class concept further clear. I have that example. I should have that example in my spring code March 26, right? Yes, I have it, a random number. So you can see here, yeah, this has to be with the constructor. So in this simple example, I have created class of an object of the class random, and passing 3 means generate random number between 0 to 3, right? And then even if you do not provide this number here, it should still be fine. And then you say give me a random number between 0 to 3. Now if I save this program, I've done it for 10 times, right? So you can see from I is equal to 0 to 10. So I've done it for 10 times. So every time this statement will be generating a random number between 0 to 3, and then I'm displaying that random number, right? Let's compile this program and then run it. Java C random number Java, and then Java random number. You can see 2 2 0 1 0 2 0 2 2 0. If I run it again, a different sequence might be generated: 2 1 2 0 2 0 2 0 1 1. So you can see this generates a number from 0 to 3, but not including 3. Remember that, right? So you actually provide, you create object of class random, and then whenever you call this next int method, you provide the range, and between 0 to that number, a random number will be generated whenever you call this method, right? I hope this concept is clear now. We will be using this concept here in this example. So what I do here, let us see dynamic method dispatch, right? This dynamic method dispatch concept will be quite interesting when you combine it with this random number generation. So here I do for integer I equal to 0, I less than, say for example 10, and then I plus plus, right? Okay, and then on every iteration I say integer number equal to, I'm going to generate a random number. I say next int and 3. It means generate a number between 0, 1 and 2. Right. Now see what I'm going to do. This is quite interesting. Here is the dynamic method dispatch in action. I say if number equal to 0, if number equal to 0, then I say A equal to C. A equal to C. It means that the reference of animal is going to get object of class cat, right? Else if number equal to 1, then I say A equal to D. It means this will get the object of dog, right? This will get object of dog, and then I say else A equal to H, right? So depending on, if number is 0, A will store cat. If number is 1, A will store dog. If number is 2, A will get a horse, right? Here I say A dot sound. Now you know that this A dot sound is a kind of single interface, like my eyes. But what will be action that depend on runtime, what number is generated. So this might represent sound of dog, this might represent sound of horse, this might represent sound of cat. But that all depends on what number is generated at runtime. So this method dispatch, the association or the binding of the sound method with A will actually depend on runtime. It depends on what random number is generated, and accordingly we are going to associate a method either from cat or from dog or from horse. So you know that the output of this statement will be decided at runtime. You cannot decide at compile time what will be output of this statement. Absolutely not, because this A dot sound is a kind of dynamic method dispatch. The method which we are going to dispatch on reference of animal will heavily depend on what number we are going to generate at runtime. If it is 0, A dot sound will be cat. If it is 1, A dot sound will be dog. If it is 2, A dot sound will be horse. Right. So every time we just display this number, and then our for loop is closed. Here the for loop is closed. Then our main method closes, and then class closes. Right. So let us see behavior of this method. Let us see which method we are going to call at the runtime. How many times we see dog, how many times we see horse, and how many times we are going to see the cat. Right. So it has been saved. CLS Java C animal demo.java. Right. Okay, so you can see this random class is coming from java.util. So I need to import package the java.util. So import java.util.random. Right. So I'm saying that import a package from import a class random from java.util package. Right. There was another error on line number 8, no type defined, no println. This has to be println. Okay, control S. Java C, great. Java animal demo. You can see here, this is horse, this is cat, dog, cat, horse. So you can see for all the 10 iteration of loop, the statement is same, A dot sound. But the sound method, where it will be called from, this binding between reference and method has been done at runtime. So A dot sound here says sound of horse, then sound of cat, sound of dog, sound of cat, sound of horse. If you run it one more time, it may have different output. You can see this execution was not decided at compile time, because had it been decided at the compile time, it would have produced same output every time. But here you can see execution is different, and here execution is different. So this is a sound of cat, sound of dog, horse, and so on. So you can see this is exactly the concept that we have in the real time, in real world. In real world, we say that I have my eyes, and what action I'm going to take by using my eyes, that depends on runtime situation. Right? If I see a danger, I will run away from danger. But if I see something attractive, I will run closer to that item. Right? So this actually shows by using my eyes interface, I can take multiple actions. An action of running away and an action to coming closer. And that depends on what I perceive at the runtime. So same is the case here. A dot sound is same interface like eyes, but what sound it will generate, it depends on runtime environment. And here, the runtime environment that we have decided, it is just a random number. But you can also decide runtime environment by many other ways. I mean, as you move along, you will see that this runtime environment is not only about random number. These are actually many other concepts. Runtime environment will actually see multiple inputs in the environment, and then depending on those multiple inputs, it is going to take some actions, right? For example, some of the actions are dependent on the weather, some of the actions are dependent on the road traffic. So all these runtime values we are going to extract from the environment and then take an action accordingly. So here you just saw a basic understanding of polymorphism. As we move in our future programs, we'll see more polymorphism in action. I'm going to stop this lecture here. I'm going to upload this code on LMS, and if you have any question, you will be posting to this week's forum. Thank you very much.